drained and hot, ready to learn. I love that. I love that. I love the ready to learn. Who else? There are quite a few persons here, you know, and I'm only seeing Hoshan. Hosh. All right, this is what I want you to do for me. There are just about, how many of us are here? I think I saw 40 something the last time I checked. 40. So I want you to take a minute, look in the chat, look in the participant list. I mean, if you're not seeing your friend or your classmate, send them a message, call them quick and tell them to run come. I'm giving you 2 minutes and I'm going to start in 2 minutes. Message your friend and tell them to run come because they don't want to miss this morning session. 2 minutes. All right, so while you are messaging your friend, these are the items that you need. We're looking at bearings and trigonometry this morning. So you most definitely need a calculator, a scientific one that is. You don't necessarily need your protractor, but it would be good if you have it. You definitely need your book and your pencil and your pen and a ruler. We're practicing, you know, because it's so CSEC time. So we're practicing. So gather your stuff. 1 minute to go. Gather your stuff and let's start in a minute. All right, I've seen some more persons coming in. So I know that you're telling your friends. All right. So let's go now. Let me hide these things. You can also tell your friends that we are about to go live on YouTube. The link will be placed in the chat shortly. So if they don't have Zoom and they don't want to come on the Zoom on their devices, we are also going to be live on YouTube. And at the end of the session, give us about a day or two. The recording from the Zoom will be placed on our YouTube channel, so you can always go back and check. Just in case you miss something or you just want to go over the questions and practice in preparation for the examination. Oh, once, okay, all right. All right, so this is what I want you to do for me now. I want you to type the name of your school in the chat so we can get a little register to see the different schools that have been represented here today. So I'm giving you 1 minute to type your school name in the chat. And right after you type your school name, just go ahead and look if you see all your friends and your classmates. And if you forgot to message 1 or 2 of them, then just shoot them a message quick. So I'm seeing Calabar, Dunoon, Pembroke Hall. Lots of Calabar people out here this morning, man. Kingston High, JC, Cumberland High, Mona, a lot of Dunoon and Calabar, Merle Grove. That's where I went. Hi, girl. Tarrant, Queens, Vauxhall. All right, representing. Tivoli, nice. Holy Trinity. I'm seeing too many one person type in some schools, and it means that some of your classmates are not here. I'm seeing a lot of Calabar and Dunoon. Tivoli, check on your classmates. Vauxhall, check on your classmates. Tarrant, check on your classmates, man, and tell them to come. Wake up. Charlie Smith, wow. Hello. All right. Remember to also rename yourself so that I can see your name, please. When I'm addressing you, I would love to address you by your name. Andrew, make your say so. You're tired. All right, St. Catherine, hi. Okay, hi, Gabriel. Listen, Scott, you're already renamed, but you can send a private message to Giovanni Limi if you don't know how to rename yourself, and he will assist you with that. If I'm going to be honest, I myself, I'm not sure how to do it. What Mr. Limi does. So send Mr. Limi a private message, and he will help you out with that. Or even just type in the chat, please rename me, and Mr. Limi will assist you. Put your name in the chat, and Mr. Limi will assist you. Cumberland High. All right, so here we go now. We're starting for real. So as we get ourselves a little bit warm, I'm sure a lot of us know this game, 4 picks, 1 word. I'm going to show you 4 pictures, and I want you to type in the chat the word that you think matches the images based on the letters that are available. Which word do you think these 4 pictures are representing? All right, Chris fast on it, man. Chris, can you send Mr. Limi your information, please? We have a prize for you. What's the information? Your telephone number and your service provider. You just won yourself $100 call credit. Yay! So send Mr. Limi your information and we will get your credit to you. Angle is indeed the correct answer. What about this one? What about this one? Pyramid says Davian Davis. I'm not sure about that. PXL, I'm not sure what's your name. Don, Triangle. What kind of sign? Oh, you actually can get sign out of the. Oh, okay. So this one is this one is actually triangle. All right. So we're focusing on angles and triangles, basically. So during this session or at the end of this session, I'm hoping that you'll be able to determine relative position of 1 or 2 points given the bearing of 1 point with respect to the other. We're going to explore the trigonometric ratios, sine rule, cosine rule, and we're going to solve some problems involving bearings and trigonometry. All right, so what is a bearing? I should have asked you now, what it come up already, so I'll just go ahead. So bearings are angles measured clockwise from north. Simple. It's an angle measured in a clockwise direction from north. We do use bearings in real life. Anybody can tell me one aspect of real life that a bearing is used or bearings is used? Type in the chat, turn on your mic. Anybody can tell me in real life where people using bearings. So we use a compass to measure. Gabriel said in a wheel, not that kind of bearings, sweetheart, in the car. But if it not bearings, the car mash up. Not that kind of bearings. So I'm seeing, it's actually the Cartesian plane, not cardigan. Cardigan is a sweater that you wear. So we use ships, we fly plane, cartography. McCarthy, would you like to tell me about that one? Navigation, aviation. Do we use bearings in construction? I am not sure. I don't know about that part. But if you are sure, you can enlighten me. So definitely, if you plan to be a sailor, a pilot, whether you are work plane, ship, if you work in aviation, you definitely need to know about bearings because it is what helps you to navigate the sea and the airspace in getting to your destination. All right, we're not talking about the bearings in a transmission, not that kind of bearings in a car or a bike. We're actually talking about an angular movement in this case. All right, so before we got digitized, you know, people usually walk up and down with a compass in their hands and you have different type of compasses. And here is one, so I'm just going to show you. So as you have the compass in your hand and you move, the bearing is actually changing. It's giving you different angular measurements, as you can see. Let me run the video again. So as the person is moving, the angle is also moving. So, you know, if you want to be a real life pirate and you want to go and search for treasures on lands, you're perhaps going to need one of these because maybe if you have your phone wherever you are, the signal will not pick up, so the phone will fail you. Yeah. Just kidding. I hope none of you are not trying to be a pirate. All right. So again, a bearing is measured from north. So we're definitely looking at entire is in a clockwise direction, and it is also written in 3 figures. If you look on the diagram to the right, we take into consideration our cardinal points, north, south, east, and west. You know, you have northeast, southeast, northwest, southwest, and so on. We don't use the directions per se, but if you understand how the north, east, south, and west works, it can help you to calculate your bearings. So let's take this angle for instance. So let me go again. So this angle, if it is measuring from north in a clockwise direction, and we are writing it in 3 figures, what is the bearing that is being represented here? Let me go again. Oh, watch out, it come up. That's not what I wanted to do, but it came up. 045 was Kadisha's guess. What it came up. So that would have been, so how would I represent this bearing? So it's a 60-degree angle, but how would I represent this bearing? 060, very well. 060 degrees, very well. Because we write our bearings as 3 figures. That is very important. Your bearings must be written in 3 figures. All right, so let's try some more. First one from the left. What's the bearing you think is being represented there? So let me go again. So we're putting in that line where the circle is on the circumference. .070 Samuel. All right. Here's a question. This bearing must be more than but less than 2 particular numbers based on just our cardinal points as we are seeing on the screen. Tell me, what are those 2 numbers? So this bearing is more than a particular number. Which particular number is that? I'm seeing your guesses. 90 degrees, very well. So because if we had, let me use my laser, good. So from north to east, if I'm traveling from north and I go directly to the east point, how many degrees would I have gone? What's the angular movement there? From north directly to east, that would be a bearing of 90 degrees. Very well. And if I went from north directly to south, the southmost point, what bearing would that be? 180 degrees. Very well. So there are some little things that we can use to help us. So that means that this bearing is, as some of you would have said, between 90 and 180 degrees. So let's see if your guesses would have been correct. So this angle is about 145 degrees. This bearing, rather. What about this one? Let me go again. So it's the angle that meets the point on the circumference. What about that one? Oh, geez. I'm touching the something and the thing's coming up. All right, here's my question now. Which 2 angles would this bearing be in between for certain? Give me the 2 angles that it would be in between. 2 angular measurement. Very well, Fidel. 180 and 270 degrees. Lovely. Because, again, if we went straight to south, that would be 180 degrees from north. And if we go straight to west from north, that would have been 270 degrees. So we know that it has to be a value in between 180 and 270. And this was about 230 degrees. All right, what about this one? The third one to the right. Again, which 2 angles would this bearing be in between? Which 2 angles would this bearing be in between? 270 and 360 degrees. Lovely, wonderful. And this was about 315 degrees. All right. So you want to use your knowledge of the quadrants and the cardinal points, and knowing that if when we go from north directly to east, that's 90 degrees. We go direct from north directly south, 180 degrees. Directly west, 270 degrees. And if we come all the way from north back to the northmost point, that would have been 360 degrees. So you can use that information, to help you when you are solving problems with bearings. So as a matter of fact, it gives you an idea of estimation, because one of the skills that you should have as a good math student is estimation skills. So when you look at your answer, if you get a diagram and you are asked to calculate a bearing, based on the answer that you get, you should be able to tell if your answer is within a correct range. So you should know that your answer, for example, should be between two particular numbers. So it should be no more than or no less than a particular number. So if you get an answer that is outside of that range, then you know for sure that your answer is incorrect. Or if you get an answer within the range, then you can feel comfortable to say, all right, 100% it right, but it look about right. You should be able to look at your answer and say to yourself, it look about right, or no man, the answer you're far off. Let me recalculate. All right. So so we're gonna throw our answers in the chat quickly. Oh, this time we have a compass to help us. So we are going around the circumference, and remember, we measure.
Sorry, Miss Protractor, not compass. You have
compass, sorry.
Occupational hazard. No, not compass, protractor.
Protractor, did I say?
Compass.
Compass, oh Lord. Protractor, thank you very much. Protractor, pair of compass, but a protractor. Always mix up those two words. Protractor, and it's on screen. Read what you see and don't listen to my voice. Just kidding. All right, so we're using our protractor to help us this time, and we are looking at the different points along the circumference. So going around the circumference, and remember, we measure from north in a clockwise direction, and we always use 3 figures. Oh, but the answers come up. That's not nice. What about the third point? So I did the first 2 for you. What about the third point? All right, and the third point was 80 degrees. Some persons were spot on, 080 degrees. Very good. All right, what about the next point? So I did that one for you. What about the next point? You see that first person who typed 110, I am not even going to call the name that you have written on your thing. If you could change that name, I would greatly appreciate it. $135 degrees, some persons are spot on. What about the next one? $160, some persons were spot on. And because our protractor is there for us, we don't have to guess. It's right there. All right. But I also want to pause here to caution you that when you go into the exam, you won't necessarily be able to use your protractor to measure the angles because the diagrams on the exam paper are not drawn to scale. And you are usually required to do a calculation to determine the bearing. All right? So I want you to remember that. Don't go into the exam and use your protractor to measure unless they told you to measure. Usually, you are required to do some form of calculation to determine your answers because your diagrams are not drawn to scale in the examination, on the examination paper. All right. So how do we measure a bearing from one point to another? Here, this question is asking us to find the bearing of B from A. Now, the first thing we need to know is where is our starting point? Where are we starting from? Where is our starting point? Where are we measuring from? Are we measuring from A or are we measuring from B? Where are we measuring from? So I'm seeing some person saying B and some person saying A. So let me read the thing. We're finding the bearing of B from A. So where are we starting from? Samuel shouting, you know? Samuel is so shouting in the chat. Samuel is shouting. So we are measuring from A. It says it in the thing, you know, from A. So it tells you where you should be measuring from. The word from is literally there. So, all right. So we have 2 points. How do we go about measure? The first thing you want to do is to draw a line segment connecting both points. Because you're going to need that line. It will form a part of your angle. Then our next step is to draw a north line at our starting point, and that is A. So we put a north line at A. Why? Because we measure from north in a clockwise direction. That's how we measure our bearings. From north in a clockwise direction. So a north line is very important. That is our starting point. Then we measure the angle between the line segment and the north line. So here is our angle. What angle are you seeing on screen? Very good, Giovanni, with the representation of our angle. Very well. Nobody didn't slip up. Samuel, forget to type him 0. But I know that is the second 0 you forget, Samuel. Good. Nobody didn't slip up. Very well. So this angle would be 60 degrees, and we write that 060 degrees. Very well. Don't forget that we write bearings as 3 figures at all times. All right. What about the bearing of A from B? Where's our starting point? Somebody's microphone is open. Where is our starting point? We shouldn't have any varying opinion right here, so now you know. Everybody should be saying the same thing. Very well. Our starting point is B. But what is the first thing that we do? We have 2 points. What's the first thing that we do? Somebody open your microphone and tell me quick. What's the first thing that we should do?
Draw a straight line.
Draw a line.
Line what? Is that line me drawing? It's not a line.
Line segment.
Draw a line segment.
Line segment,
line
very
segment.
good, because it has 2 endpoints. It is a line segment. Very good. So we're connecting A and B. Don't watch that my line segment is kind of off. You know how the technology go. What's our next step?
Put up a north.
And where am I putting that north line?
B.
A or B?
Put it on the front point. Put it on the front point.
B.
And the front
Put it on
point
the
is
front
where?
point.
Where's the
B.
front? B. Very well. So we're putting a north line at B. And we're now measuring the angle. So here's my question now. Where is the angle? Is it on the outside of B or is it on the inside on the left side? Where's the angle that we're measuring?
It's on the outside.
The left side.
Outside.
Left or right? Tell me where the
Right.
angle will be.
Right.
Left or
Right.
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 We're going clockwise.
Very good. We're going in a clockwise direction, so our angle will most definitely be on the right side. From the north line, coming all the way around to our line segment. What angle is that? What angle is that? 240 degrees, the people said. All right, very well. Remember again, when you are in your exam, unless they tell you to use a protractor, please don't. I am only using a protractor just to help you to measure the angle so you can see the angle. But generally in the examination, unless they ask you to measure it, don't do that. All right. So we would have done this basically. And we already established that a bearing is a way of defining direction as an angle measurement from due north in a clockwise direction. So we measured our angle from A to B, and we got 60 degrees. And we also measured the bearing, of A from B, and we got 240 degrees. Right? I also want to point out that a bearing is an angle between 0 degrees and 360 degrees. So your bearing would not be 500 degrees or 449 degrees. Your bearing is usually an angle between 0 degrees and 360 degrees. Can you identify any relationship between, can you identify any relationship between the two bearings that we would have calculated from A and B? Is there any relationship between these two angles? Somebody said co-interior angles. I wonder if Khadijah or Davian would like to turn on their mic and explain to me what they're talking about co-interior angles. Khadijah or Davian, would you like to tell me? Oh, Davian, your mic is not working. Khadijah, would you like, is Khadijah? Yes, Khadijah. Mackenzie, would you like to explain co-interior angles? I'm seeing John Tay saying alternate angles, as well as M. Walker and Mikino. If I'm mispronouncing your name, I sincerely apologize. I sincerely apologize. Any of you who typed in the chat, would you like to turn on your microphone and tell me why you would have chosen the type of angles you chose? Look here, what are we doing now? Now have microphone issues. Is honesty, so? I don't love the style there. Nobody microphone. Stop that. Stop that, Nikki. I would love if somebody would turn on their microphone though and explain to me the type of angle relationship that you are seeing.
Miss alternate angles.
Explain the alternate angles for me, please, Davian.
Miss alternate angles are angles that occur on opposite sides of the transversal line.
Mm-hmm.
So like how the 60, so like you have the 60 degrees up and the 240 degrees down. They're on the same, on the opposite side of the transversal line. But
All right, so thank you, sir. By virtue of the fact that we knew that, where's my laser? Let me get my laser. We calculated this angle and we got 60 degrees, as Davian and other persons would have said. Right here would also be 60 degrees because they are alternate. Remember, our two north lines would form parallel lines, and then the line segment that we would have drawn to connect both points would have been a transversal. So by virtue of the fact that this angle is 60 degrees, this angle is also 60 degrees. And you can use that information when you have your questions to assist you without, without the protractor. If knowing that this angle is 60 degrees, how could we use that information along with the rest of the diagram to get this 240 degrees? Tell me. Great. Because of the north line, I'm seeing 180 plus 60. So because of this north line, we know that the angle from north in a clockwise direction, meeting that same extended north line, this entire angle here that is white would be 180 degrees. And we know that this is 60. So the 180 plus the 60 would have given us 240 degrees. So I want to also remind you here that sometimes we learn about different concepts in math and we leave it where we learned it. In bearings, you're going to need your triangular information. You're going to need types of angles information to assist you. So and different aspects of math requires a combination of different concepts. So I don't want you to learn the things and leave them in the week that you learn them. You have to remember because you're going to need the information to assist you. All right? Okay. So we're going to try some now without me talking. Here we go. What is the bearing of X from Y? Light up the chat. Bearing of X from Y. Quick question. Where is your starting point? Where are you starting from? Where are we starting from? We shouldn't have a varying in opinion with this one. All right, great. So we know where we're starting from. What is our angle now? Our bearing, sorry. What is our bearing? So this red portion is what we want to get. Look again, this red portion is what we want to get. Here's my question though. How did you find your answer? How?
Miss, we subtracted the 120 from the 180.
Why? Why are we subtracting 120 from 180?
We subtracted 120 from 180.
Why?
Miss May.
Yes, Fidel, go ahead.
Okay. The reason why we subtracted 120 from 180 is because angles on a straight line adds up to 180. And since we already got the value for the 120, so we just subtract it from the 180.
Fabulous, fabulous. Here you go again. Angles, the information about the types of lines, angles on a straight, types of angles, sorry, angles on a straight line. We needed that information to help us. All right, here we go. What is the bearing of P from Q? Where's our starting point? The bearing of P, sorry, from Q. Where's our starting point? We should all be on the same page for our starting point. Very well. All right, we know our starting point. My next question is, how are we going to now determine that angle? How? My question is how? How are we going to determine the angle? Or the bearing? I'm seeing some calculations in the chat. Laver, is that how you pronounce your name there? McCarthy? Would you like to talk to me about that calculation? Don't be shy.
Well,
Go ahead.
well, like what you said, bearings go clockwise. So when you look at the north line of P, you can basically see that there's a 360-degree angle there. So since Q is 110 degrees from P, you can subtract that from 360.
Okay.
Excuse me. May
Go
I
ahead,
again?
Fidel.
Okay, so the answer that I got differed from theirs. My answer would have been 290. How I arrived at my answer is because P gave us that it was 110, and it running on the same line as Q would mean that the angle at Q would be 110 from 180, which have been 70, and then if I do a reverse calculation, you subtract 70 from the 360, I'd have gotten 290.
So you're saying, let me, ooh, sorry. Wait. So I just want to be clear of what you're saying, Fidel. What this angle in here, you're saying is what?
70.
Because?
It runs on the same line as P, and P was already stated to be 110. So once you subtract 110 from the 180 with them running on the same line, it would have been 70.
So wait, hold on, Fidel, hold on. When you say
Okay.
run on the same line, what does that mean? I'm not sure I understand that. Run on the same line.
How could I explain it?
You're not making, are you making reference to angles on a straight line?
Yeah.
Well, no, that wouldn't be angles on a straight line because the angles will have to be alternate. They have to be beside each other.
Okay.
But there is a 180 degrees relationship. Can anybody tell or help Fidel with that relationship that is happening between this 110 degrees and this angle here? There is a relationship there. A part of your word is missing, Jason. A part of that first word is missing.
Miss, would it have been co-interior then?
Yes. Yes. Co-interior angles. So co-interior angles which are formed. Tiara, close your mic, sweetie. Tiara? Very well, thank you. So this, the 110 degrees and this angle on the inside here, let me just draw. Pen. So these two angles would be co-interior and they would sum to 180 degrees. So I do agree with you there. So if this is 110 degrees, this angle is how much you said, sir? Go again?
70.
Very well. Okay, and we need this angle, right?
Yes, miss. So we'd subtract it from 360 and we'd have gotten 290.
All right, let's see. So we heard two explanations. Let's see. So one way we could have done it. So 290 is actually correct, and that's fine. Your method is fine. The beauty about math is that there is no one way to work any math problem. So just in case somebody missed it, we could have gone the route. I don't want us to forget the route that Fidel explained to us. So we could have gone the route. Okay, how we know it's 70, not a problem. So this angle here, as Fidel would have explained, would have been co-interior with this 110 degrees angle. So two angles that are formed in between two parallel lines and the transversal, PQ would have created a transversal. When they form a C or a U, we can consider it a U like this. The two angles on the inside on the same side of the transversal would sum to 180 degrees because they are co-interior. So if this is 110 degrees, then this angle here would be 180 subtract 110, which would be 70 degrees. All right. Now we want to find this angle coming all the way around. We know that both of these angles should sum to what? Both angles should sum to
360.
360 degrees. So if we know that one angle is 70 degrees, all we need to do is to subtract the 70 from 360, which would give us 290 degrees, 290 degrees. So that's one method, that's Fidel method, and that's fine. Now the method I used would have included our knowledge of co-interior angles. So, not co-interior, alternate, my bad, alternate angles. So this angle, so we would have given an angle of 110 degrees, let me use my laser point, 110 degrees. And if we extended our north lines like I did, so this is what we were given. So I extended my north lines so I can have that nice parallel line and transversal situation happening there. And I know that if this angle is 110 degrees, then this angle here would be 110 degrees because they are alternate. They form Z angles. All right. And then I know, so I got that 110 degrees, and I know that this angle here is 180 degrees. So all I need to do is to sum the 180 with the 110. So if you use any of those methods, that would have been fine. Is that clear? Did I lose anyone? I don't want to lose you, you know. Let me know if you understand both methods. Did I lose you? If I lose you, just type in the chat, lost me. Miss you lost me. Okay. Clear, crystal, very well, lovely. All right, one person is a little lost. I want it, okay, no problem. Yes, it will be on YouTube. Where did I lose you? Go ahead with that raised hand, Kenito. Go ahead. Kenito. Okay, I lost you at the first method. So the second method is fine. All right. So I will go one more time, not a problem. My aim here is to ensure that we all leave with a better understanding and not confused. So please feel free to let me know when I need to go over something, because I don't want you to leave and you don't understand. All right. So, okay, here we are using back Fidel's method. So Fidel realized that this angle here, I'm going to shade it. There's a relationship between this angle in red and the 110 degrees that we were given. What is that relationship? These two angles should sum to 180 degrees because they're what we call co-interior. How are they co-interior? Because they are on the same side of the transversal and in between two parallel lines. All right, we could extend those lines, those north lines, we could have extended them and it looked more parallel to you. So when you have two north lines, they will be parallel. All right. So if we know that co-interior angles sum to 180 degrees, we can find this angle by doing what? Tell me. Kenito, John Alicia? Sorry if I mispronounced your name. Cherish? Tell me, how can I find that red angle there? What am I subtracting? I think it's 110 from 180. 110 from 180. Very good. Shaira and Kenita, I think you subtracted those numbers in the wrong order. So we know that both angles sum to 180 degrees. So we are subtracting 110 from 180. And when we subtract 110 degrees from 180 degrees, what do we have left?
70.
70 degrees, lovely. So we know that this angle here is 70 degrees. But that's not the angle that we want to find. Let me get a different color. We want to find the bearing of P from Q. So we start from our north line and we're going all the way around to the line segment. So we need to find all of this blue portion in here. So all of this blue. Based on the information that we now have, how can we determine that angle that is in blue using the information that we have? How can we determine that? For the persons especially who said that they didn't understand, that question is for you. Good. So we know that the red portion and the blue portion together, it would have given us an entire revolution, which is 360 degrees. So if we have this red piece and we need to find the blue piece, we simply subtract what we know, which is the 70 degrees from 360 degrees, which would give us what? Come people.
290.
290 degrees. Very well. And that is that. That is that. Is that clearer for the persons who were having a challenge? Go ahead, Kenito. How did I get 360? So remember, you know, that a full turn. Where's my pen? Where's my pen? So a complete turn at any point, a complete turn would measure 360 degrees. That's a given. So all the angles at a point, the entire set of angles at a point is 360 degrees. That's a given. That's a given. I can't tell you what is the name of the mathematician who came up with that information, but that's just a fact that we know in life. The angles at a point or a complete turn measures 360 degrees. That's just something that we know. Is that clear? All right, do I need to go over the second one, or it was just the first one that was giving us a challenge? Tell me quickly so I can move on or go over. Are we okay now?
Yes, miss.
Okay. Okay, second one was clear. All right, very well. Lovely. All right. What is the bearing of W from O? Where is our starting point? Are we starting at W or O?
O.
Oh, miss.
Very well. So what is our bearing of W from O? No, Davian. Davian and Den. Could
Yes.
Davian and Den, I want you to tell me. And Fidel. Are your answers reasonable? Based on the angle? Let me draw. Wait, I think it should come up. This is the angle that the bearing. That's the bearing, you know. Thank you very much, Chris. Chris is saying that it has to be more than 180.
Oh, yes.
Look at the size of the angle. Remember, we're starting from our north line and we're going all the way around. We did say that our starting point is O. And we're looking at that reflex angle at O. So by no means could it be 50 degrees. By no means. Look here, Miss Shaira. I don't want you to guess, you know. We're going to put in question marks. We're going to put in question marks at the end of the numbers, people. Can somebody turn on their microphone and tell me how it is that you are calculating this angle? You shouldn't have a challenge with this one, you know, but it's okay. Come, tell me. Let me, Jaimari? If me and butcher on the name.
130 from 360.
130 degrees from 360. Why 360 degrees? How you get that number? Or why you choose to use 360 degrees? Why are you subtracting from 360 degrees? Come now. John Alicia. Who else miss it over here subtracting? PXL, your subtraction is not in the right order.
Miss, may I help them?
Who is may I?
It's Phil. The reason why we use 360 is because a full rotation is 360.
Okay. And
hence we would subtract 130 from it because we were given an angle stating that the angle at O was 130, and so we'd subtract the 130 from the 360 to get the angle at W, which would have been 230.
all right. We can also see that the entire rotation or angles at this point at O was shared between two angles, the 130 degrees and the bearing of W from O. So we're having only two angles being identified in the image. So if one angle is 130 degrees, we know that a full rotation is 360 degrees. So we simply subtract the one that we know so we can get the one that we don't know. Is that clear? Have I lost anyone?
No, you haven't.
All right, I'm not seeing anybody saying I'm lost. Okay, last one. What is the... All right, you're found. Very well. Very well. I'm glad you're found. I love when we're all here together. When we are on this train, we call it no man left behind. All right, we're not running ahead, leaving anyone. We need everybody to be on the train with us. We don't want anybody to come off at any stop and throw them and say, why me can't bother? No, we're all getting to our final destination on the train. We're on destination 1 in a maths. That's where this train is going. All right, what is the bearing of A from B? Where's our starting point? Where's our starting point? What is the bearing of A from B? Starting point. Good. Great. So we're starting at B. What type of angle is that A? Is it an obtuse, acute, reflex? Which of the angles are we looking at
Acute.
At B, sorry. Is it though? Is B I mean to say, sorry.
Obtuse.
Some people don't know them types of angles, you know. As I see 3 different type of angle type in the chat here. Or maybe it's because I said the wrong thing initially. It's an obtuse angle. Then you say it can't be acute. That is true. But why? What value would it have to pass for you to know that it's not acute? What is the stopping point for acute angles?
89.
89. 89.99999. Yes. So it is an obtuse angle. All right. Talk to me about the measure now. This one is pretty easy. How are we going to find this angle? How are we going to find this angle? That's the angle we want to find, or the bearing that we want to find. Okay. Look at me, Kina, subtracting 504 from 360. Makina, where you get 360 pumpkin? How did you get 360, darling?
Him says a mistake, miss.
Okay, I think it's the 504 was the mistake and not the 360. Kyle, your subtraction sentence is in the wrong order. If you subtract 180 from 50, you would get negative 130, not a positive. Students, I need you to be a little bit more precise with your representations. Too many of you are making that mistake of writing your subtraction sentence incorrectly. Okay, very well. And we know that that is angles on a straight line. No problems there. All right. Here we go with some CSEC questions. So here we have a diagram and I need you to sketch the diagram in your book. I need when you leave the platform, you have something to look back on. So I need you to write down the questions. You don't have to use your ruler to be neat and fancy, but have a sketch. So the diagram below, not drawn to scale, shows the positions of 3 ports. Port P, port Q, and port R. So we're on water, ports. Q is 80 kilometers from P, as you can see. R is 100 kilometers from Q on a bearing of 66 degrees. Angle PQR, as you can see, is 54 degrees. And the question is asking us to calculate the bearing of P from Q. The bearing of P from Q. So I'm going to give you 2 minutes to draw your sketch and calculate your bearing. Let me put it on the clock. 2 minutes on the NCB Omni Insurance clock. And the time has started. And I hope you're trying for yourselves, you know. I don't want you to just sit and write off the answers. I need you to try on your own. And I need you to write something in your book. It is a fact that when you write, it helps with retention. And remember, we're on the train to 1 in CSEC math. I wonder why Jonty asking me a question. Jonty, I don't want you to ask me a question, you know, I want you to tell me. I want you to say it with your chest like you're sure and you know. Yes. Put full stop, end of sentence. I want you to, yeah man, I want you to be sure, be confident in your response. $30 to, no, that's not true. 40 seconds to go. All right, Nikolai got 126. 2% got 120. 120 degrees. And I hope, even though you're at 120 in the chat, I hope you have your degrees symbol in your books. Please don't forget your units. I'm only accepting the number only because I know it's a little difficult to type in the chat. The 2 minutes are up, and I'm only seeing 4 responses in the chat. You know, say this individual though. Come on, I need to see some more responses. So I'm seeing, so it's between 120 and 126 degrees. I'm seeing some person saying 120, and I'm seeing some person saying 126. What says the others? I think this is about 7 responses, and there are, how many of us here? Wow, 100 something. Come on, I need to see some more responses in the chat. I don't want you to type an answer just because I see somebody typing it in. I hope you, all of these answers I'm seeing were actual calculations that were done. All right. So the first thing you know is which angle we're calculating, and that angle is represented in yellow on screen. I also like to represent all of the information that is given me in a question on my diagram. Now, if you notice, not all of the information was represented. There was also a 66 degrees that was given. And we want to find that angle right there. How do we go about finding that angle? We sum both angles, and that should have given you 120 degrees. Yes, Kenito?
Miss, you add both the angles and then you subtract both angles from it.
Why are you subtracting, sweetheart?
No, miss, because we're still trying to find P and then.
That's it. This is it. There is no subtraction. This is it.
Oh, all right.
This is the answer. That's all we needed to do. This is the answer. Remember, we're only trying to find the angle represented in yellow. So there is no need to subtract anything. This is it. All right, here's another question. From the harbor H, the bearing of two boys. Miss Harris, boys?
Yes.
Yes, miss. It's boys.
Okay, boys. Okay, so the bearing of two boys, S and Q, are 185 degrees and 311 degrees respectively. Q is 5.4 kilometers from H, while S is 3.5 kilometers from H. On the diagram, which shows the sketch of this information, insert the value of the marked angle QHS. All right, so I'm giving you a few minutes to sketch your diagram. And again, insert all of the information that you were given in the prompt, which is the worded part. So put in all of the information, not just a little information was inserted for you. So I need you to insert all of the other information. Three minutes to do a sketch and put in your information. I'm going to start the clock. All right. Oh, the 3 minutes not finished yet. 3 minutes long, man. All righty. All right. So, have you drawn your diagram and put in all of your information already? Hello. What you saying, Lavier?
Finish?
I thought you were saying something to me.
Oh,
Okay. All right, so the question asks us to find or to insert the value of the angle marked QHS. This is the angle in red. That's our angle QHS. What do you have for the value of angle QHS? Talk to me. What do you have as the value for QHS?
Excuse me, Mr. Rai, could I ask a question, please?
Sure.
Would anyone like to share with us if you're writing the bearing for H to Q, where would you stop that line segment if we were drawing the arc to represent that angle? You'd start at the north line, and where would you stop? Where would that 311 stop at? Would it stop at HS? Would it stop at QS? Would it stop at QH? Where would it stop? Where would that angle stop? Because you want to know where that 311 is, because that's not on the diagram. So you need to represent that 311 and know where it is 311. Where is it? Anyone wants a chance to share with us? Okay, Giovanni says HQ. All right. So it would mean that that big angle would be 311. Thanks for that, Giovanni. So if you have that 311, go on, I just want to see them more sure where to put the 311 is. You can continue.
Okay. All right, so as Giovanni would have indicated, there goes our 311 degrees, 311 degrees. I hope that's where you had your 311 degrees. And it still remains, we need to find that angle represented in LQHS. So how can we use this information that was given us to determine the angle QHS? Talk to me. It's right there on screen. So I'm seeing 2 persons in the chat. What say the others of us? Moya, is it possible based on the size of the angle, even though it is not drawn to scale, for the angle to be 49 degrees? Please note we're trying to find the angle represented in red. Could that angle be 49 degrees? Just by the diagram. So you're not looking for the angle that where H is. We're not looking for the angle where H and the arrow is. That's not the angle we're looking for. We're looking for the angle inside of the triangle represented in red. And as some persons rightly typed in the chat, we would have simply subtracted the 185 degrees from 311 degrees, which will give us 126 degrees. Are we all seeing that? A few persons would have seen it and typed it in the chat. Did I lose anyone? I don't want to fall asleep on me now. Come on, wake up, wake up. Do we need to do hands up, sideways, forward, touch your toes? Do we need to go back to the primary school settings? I don't want you to fall asleep on me. All right. Oh, this says let's take a break. So here is the question. So the presentation is in two parts. The second part entails looking at trigonometry and some more bearings. I did not want to start the trigonometry and we break and you forgot what we discussed. Break should have been at 11 o'clock. Do you want to break now at 10:30 as we are and come back at 11:30? Or do I do the 30 minutes up to 11 o'clock and then we break at 11? Just go to 11. All right. You will have to remember all of the things that we discussed, you know. You will have to remember all of the things that we discussed. All right. Break at 11. All right, no problem. Not a problem. All right, so what we just did is a simple part of just calculating a bearing from one point to another. Now, your bearings questions will come with, will be a little bit more complicated than that. And it will require some more information or some more knowledge, some more concepts for you to be able to complete the entire questions. And those concepts are Pythagoras' theorem, trig function, so you definitely need your calculators now, and the sine or the cosine rule. So you need to remember all of these things when you're calculating a bearings question. Now for the paper 2, you will get this formula sheet. However, for paper 1, which will have questions on it, you won't get a formula sheet. And so you will need to remember the things. All right? So for paper 2, you will get the formula sheet. So just in case you forget a formula or something, but for paper 1, you won't, and there will be questions on it that will require you to remember some things. All right? So I want you to look at these 4 triangular problems, and I want you to tell me in the chat which trigonometric concept you would use to calculate the unknown measurement, which is wherever you're seeing the question mark. So I want you to type 1 and then say which trigonometric concept you would use. So let's do number 1 first. Number 1, which trigonometric concept you would use to find the missing side that is labeled with the question mark?
Sine.
Is who that? So I see some person saying, so one person saying Pythagoras theorem, and then some person saying sine, some person saying cost. Is it cost? Sine, trig ratio, sine rule. Somebody says sine rule, cost, sine. All right, we will know soon. What about number 2? What would we use for number 2? Let's go to number 2. What would you use for number 2? Finding the side with the question mark. What would you use for number 2? All right, some person saying cos. I saw one person tan. All right, what about number 3? What about number 3? We're going to discuss them. I just want to hear what you're thinking first. I'm seeing sine, cosine, I'm seeing sine rule. I'm seeing sine rule. Sine rule, sine rule. All right. What about number 4? What about number 4? Cosine rule, cos, cosine rule. All right. I hope you remember your responses. As we go through, you can make a mental note of whether or not you were spot on or not. And if you weren't, it's fine. Remember, we're all here on the train to learn. So if we have a right angle triangle, we were given 2 sides and we need to know one side, then we could simply use Pythagoras' theorem. Can somebody remind me what is Pythagoras' theorem? Can somebody remind me of that formula?
A squared plus B squared plus C squared.
All right, A squared plus B squared equals C squared, says Samuel. I'm seeing somebody typing it in the chat, but I'm not seeing a name. I'm seeing a full stop. So I cannot, I don't know who that is. All right. And we also know that Pythagoras' theorem is a tool for right angle triangles only. We only use Pythagoras' theorem for right angle triangles. So if we have this triangle here, where would we label? Let's start with C. Where would we label C?
The longest side.
The
hypotenuse.
The hypotenuse, aka the longest side. Now I want to tell you that whichever side you label A or B does not matter. C is the most important side, which is the hypotenuse. You can always interchange which side you choose to label A or B. But for any given question though, If you are calling the vertical side A, that has to remain A. And if you're calling the horizontal side B, that has to remain B for that question. But generally, you can label either of those two sides A or B, but the hypotenuse is always C. All right? And that is that. Now, when do we use Pythagoras' theorem? Other than, of course, it's a right angle triangle. When do we use Pythagoras' theorem? Tell me.
Find the hypotenuse.
We can use it to find a hypotenuse. So if we're given the other two sides and we need to find the hypotenuse, is that what you're saying? Who was talking? Do we only use it to find the hypotenuse? No. So if we're given any two sides and we need to find the third side, any two. So whether we're given the vertical and the hypotenuse, the horizontal and the vertical, or the hypotenuse and the horizontal, any of those, any two, and we need to find the third side, and of course, it has to be a right angle triangle. All right. What did we say about this one again? What would we use to find this one again? Question though, why couldn't we use the trigonometric ratio? Let me go back to why couldn't we use a trig ratio to find this, or could we? But let's go. Why couldn't we use the trigonometric ratio for this question? Very good. And is that Lavier is McCarthy? Is Lavier your name? Is your name pronounced, sir?
No, miss.
So why you not correct me? How you pronounce your name, sir?
Miss, it's Laveray.
Laveray.
Yes, miss.
Oh, because of the accent on the E. Laveray. That's such a fancy name. All right. As Laveray says, no angle was provided. And we're not talking about the right angle. We weren't given a reference angle, so we could not use a trigonometric ratio. Very good. All right. On to the next. What did you say now about this question? Some person said cos. So we know for sure we can use a trigonometric ratio. Which one we would use? That's a different story. But we know for sure we can use a trigonometric ratio. We were given a reference angle, we were given a side, and we need to find another side, right? And we know that when we are using our trig ratios, as it says, it's a ratio, so you need two sides. For sure, you need two sides, whether you're looking for a side or you have a side, but two sides have to be in question in addition to an angle. All right. Now, for us to be able to determine which of the trigonometric ratios we are going to use, an important skill that we must have is the ability to correctly label our triangle. Now here we have a triangle ABC. What's the name of that side with the question mark?
Hypotenuse.
Hypotenuse.
All right, I know that we can't miss with that one. We cannot miss with that one. If you are having a trouble with identifying your hypotenuse is always opposite your right angle, directly across from your right angle. What about this side?
Opposite.
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 Because it opposite the angle.
Very well. This side opposite, and it is always opposite the reference angle, directly across from the reference angle. And clearly this side is your
Adjacent.
adjacent side. And I want to tell you that your adjacent and your hypotenuse will be the two arms of your reference angle. So the adjacent side and the hypotenuse usually creates the reference angle. All right? What about this triangle? What would I name that side?
The opposite.
Opposite.
The opposite.
The opposite.
Very good.
Opposite.
That is directly across or opposite or reference angle. And this side?
Adjacent.
Adjacent. Good. Or adjacent side is always one of the arms of our angle, reference angle. So the adjacent side helps to create the reference angle. And clearly that would be our hypotenuse directly across from our right angle. All right. Now I want you to get out your calculators. I want you to draw this table and I want you to put sine, angle, and fill out this table. So sine 0 degrees, you write that down. Sine 15 degrees, you write that down. Think you can do that in 5 minutes?
Yes, miss.
All right. 5 minutes on the clock. We will need the information, you know, very important. So I need you to complete the table. If you do not have a scientific calculator, I suggest you quickly get one. You need it for the exam. You can use your phone now and during class, but you cannot take your phone in the examination room. So you need to get yourself a calculator. You are allowed to use a calculator for paper 2 CSEC. You are not allowed to use a calculator for paper 1, which is why I need you to complete this table, because there are some things that you need to know from memory that can help you in paper 1. And if anybody here is doing City and Guilds, we also know that calculator is not allowed for City and Guilds. So you don't use calculator for multiple choice exams, but you're allowed to use calculator for short answer paper 2 questions exams. So you need your calculators. And let me tell you something, when I'm in an exam, all 1 + 1, I am double checking on my calculator. Because you know, when nerves take you, sometimes the brain fail you. So you need your calculator. Two minutes and 8 seconds to go. 30 seconds to go. We finish. Onelia, your microphone is open.
Miss,
Yes, Kenito?
Miss, I don't understand, Miss.
What exactly don't you understand?
What to calculate, Miss?
All you're putting in your calculator is sine 0 equal, you write the answer. Sine 15 equal, and you write what you see on your calculator. And so on. Cos 30, cos 45 equal, and you write the answer. That's all you're doing. You have a late start though.
And he has to know how to use.
Other than,
Maybe it is that he's not sure how to use his calculator, Miss.
I
Miss, I
don't.
think that, Miss, I think there's something wrong with 1090, you know.
Something wrong with it? What it says?
Miss, because when I put it in the calculator, I keep
There's
saying
a
math error.
Yeah, math error.
So write that word. If it's that you get, it's that you get.
Okay.
Mm-hmm.
Miss, which one him just say a while ago?
Did you do anyone that give you math error, sir?
No, you know.
Okay, good morning, everyone. I am thinking that a possible problem is not
Yeah.
with the calculator per se, but with how things are entered in the calculator. So some calculators, you enter the function first, and others, you enter the number first. In other words, you might enter sine 60 on one calculator, and the other calculator takes it the other way around. You enter 60 sine. So if you're getting that error, it could be that you have entered it the wrong way around.
No,
Right?
Miss, 'cause whichever both way I take it, I still get it wrong.
Yes, Miss, you still get that error.
Miss wasn't talking about the 1090 error. She was talking about the young man who asked earlier on about not being sure how to calculate it. And she was explaining that some calculators, you put in the value of the angle first, then the function. So you have to understand the calculator you're using when you're using it for your trig functions. So Latoya says she's finished. She's finished working on her calculations. So
So the particular problem he's having now is with a particular one rather than a general that he wasn't getting his answers all along. Is that it?
You people are talking to two different individuals.
Yes, right, yeah. Right.
But two
So he's
different
getting an error with a particular, he has been getting it okay all along, and then suddenly something is off.
Yes,
Okay.
ma'am.
Yes.
Okay, I got you now. I got it. All right. I guess we'll sort it out in a while.
All right. Who else is finished? Okay, I see 3 persons are finished. What say the others of us? All right, all right, all right. Probably only Kenito who started a little late. And that's okay. All right, very well. So, are these the values you got on your calculator?
Yes, Miss.
Look and double check, you know. You say yes too quick, man.
Miss, because it's the exact thing I got.
All right, I want you to do something for me. I want you to look on your calculator. I perhaps should have. Look at the top of your calculator. You should see a little D or DEG for degree. Are you seeing that at the top of your calculator? Kenito? Are you seeing a little D or DEG at the top of your calculator?
Miss,
No, Miss.
Yes, miss.
Wait, all right. Samuel, I'm gonna take you. I hear you no, Kenita. I'm gonna speak to you in a minute. Samuel?
No, miss, I choose for angle 0 for the cosine. A error may get to know, miss. When I get no one. Either
Well,
way.
for cosine what? 90?
0. Angle 0, angle 0.
So you put, you press the cos and you press 0 and you get what?
Error.
That means are you seeing a little D or DEG at the top of your calculator?
Degrees, miss.
Well, I'm not sure why you got
Miss, I missed it.
a mistake. Okay, all right, very well. All right, Kenita, your time now.
Yes, miss.
I want you to, do you see the mode button on your calculator?
Mode.
Yes, it says MODE, mode.
Yes, miss.
I want you to press that button for me.
It's not proceed. Miss, it's not proceed.
It's nothing not coming up?
No, miss.
I don't understand why.
You probably won't see a big number or anything, you have to look for a little D, R, or G. It might be just that little thing at the top of the screen, the top of the display.
Miss, my calculator not click good.
Your calculator do what? I'm barely hearing you. Can you speak up a little, please?
My calculator is not clicking good.
It's in what mode?
It's not clicking good.
Oh, so it's defective. I can't help you then, sweetie pie.
Sure, I asked, can the young man open his mic, his camera, and just show you what is displayed on his calculator? Maybe.
All right, can you open your camera and show us what you're seeing on your calculator? I think what is happening is that the calculator is not necessarily working well. What type of calculator are you using? What brand? Sorry.
Scientific.
What's the brand?
Join us, scientific calculator.
I don't know that brand at all, sweetie pie. Can you open your camera and show us? Just put the calculator at the camera so we can see. I can't see my video, guys. You can see?
Kenita, you have to take your hand from the top of the calculator. You're going to hold it directly to the camera so that we can see the display that you have. Your lighting is poor.
Put it more to push it more to the camera. Put it closer to the device. Oh, I don't know that one at all. Put your hand upward. I'm not seeing the calculator. I don't know the brand.
Right, so hold, right.
Much
better. Take it on a little.
SMS.
Oh, I'm seeing the mode. Okay. So when you click on mode, what you see happen? Nothing happen? Oh, it look like the battery dead, man. It look like the battery dead, or you need a new calculator because the buttons are going.
No, miss, he's pressing the middle button, not the one that's marked MODE and CLR. Not that one, Kenito. Not that one. No, come over some more. No, right, that one. Leave your finger, move your finger now. Press it one time.
There's light in the thing, Carol.
Oh, it's true, not there.
I think your calculator mash up, my boss.
Probably needs a battery.
Yeah, it needs a battery or a new calculator because even when you were pressing the button, the 0 was going in and out, which means that it doesn't have enough power. I think that's the problem.
He the calculator poorly. He presses it so rough. He might have damaged it.
All right. That look like you need a new calculator, Kenito. All right, so it is now 11. Yes, John T. Jackson.
SMS, is it okay if you round the angle, if you round it to 2 decimal places?
It's fine. That was okay.
Oh, thank you, miss.
You're welcome. All right, so it is now 2 minutes past 11. I don't want to go any further and then break. So I'm going to break here and we come back at 12 o'clock. All right. I think there's a link. Mr. Limi, don't go as yet. We're placing a link in the chat. I want you to evaluate the first half of the session, please, because I know that sometimes you leave for the morning session and you don't come back, but I need you to come back, you know. So make sure you come back. We're not going to log off. You don't have to log off if you don't want to. So I'm asking you kindly to click on the link in the chat, complete the form for the first half of the workshop, and we come back at 12 to continue. All right, so get your, I know some of you don't eat any breakfast yet. Get something to eat.
However, if you are using your data, you can log off and come back at 12.
Right.
But please remember to come back at 12.
So if you are on data and you're not on Wi-Fi, I'm asking you kindly to log off and come back at 12. So we're going to take a break now. This is the end of part 1. During the break, I need you to look at your table and write down any observations